Welcome to our webinar about news of C++ in TwinCAT 4024, especially the OnlineChange feature. My name is Henning Mersch and I'm from the product management group of TwinCAT, and I will have the presentation today about the OnlineChange feature, which we have just released. We'll take about 30 minutes for that, so maybe a couple of minutes for questions and answers afterwards. So if you have any questions, please raise them through the webinar application. We have a colleague here answering the questions, and I will try to answer general questions at the end of the webinar. If you don't get an answer, don't be afraid. We'll get a list afterwards and we could come back to you by email also. So please make use of the webinar application for raising questions. Overview. So first, let's have a small look at the agenda today, what we would like to talk about. That's mainly the OnlineChange feature of TwinCAT 3.1 4024 build. And we have some related adoptions which were required for implementing the OnlineChange there. And I would like to give you the overview of the versioned C++ projects, for example, which are one part of the related adoptions. Especially the TwinCAT loader is a new feature which could come into place without the OnlineChange. We will see later on. But we will also have a look at the Matlab Simulink integrations plans we have for providing the OnlineChange feature there. At the last point, I called it Speedrun today to just have the steps you need to know to have the first project available within your TwinCAT C++ engineering environment for accomplishing the OnlineChange there. C++ with OnlineChange, what does that mean? It's a reloading of the program code. So the executed code, which is in the runtime, could be exchanged by the TwinCAT system without going to the config mode, so without restarting TwinCAT. That's the main feature. TwinCAT below that is able to submit new versions during runtime. So if TwinCAT is in run mode and you're programming another version of your driver, then TwinCAT is able to submit this new version to the runtime system and it exchange it without going to config mode. So it's not completely the same as in the PLC, but it's comparable, and that's the reason why we decided to have it called OnlineChange comparable to the PLC. But it's not completely the same. This is a motivation for giving this webinar today to explain these differences and explain the workflow we have here. The OnlineChange feature is available from 4024 on, so you could start this evening or this morning, depending on your time zone, and just go ahead with our speedrun information and have your first look there after the webinar. Requirements and limitations. If you would like to have an online changeable object in TwinCAT, you need to have a version C++ project below that. Because we are changing between different versions, so this is the reason that you need to have a version C++ project, which is a new project template with 4024. These version C++ project results then in a TMX file, a TwinCAT Module Executable file, and not in a TwinCAT driver or operating system driver sys file anymore. So TMX files are the TwinCAT Module Executables, and these are coming out of the build process of a version C++ project. The modules within such a TMX file need to implement the ITC OnlineChange interface, where we will have a look in a minute into the details. What does that mean? These modules, which should be online changeable afterwards, are not allowed to change their data areas. So the mapping needs to remain the same because this is continuously executed in the real-time system, and the modules are only the code which is executed. This is what we are changing by the online change. The modules are in the position to change the interfaces, but you need to take care about that because everybody who is using such interfaces needs then to be prepared for that, right? Because if you have an interface pointer and this is exchanged, you need to deal with the fact that it is exchanged because maybe it's not available anymore after the online change. So take care about interface pointers if you're using them together with the online change. The TwinCAT loader is then the loader, the component of TwinCAT, which is actually loading the TwinCAT module executable files. Before that, or for the driver projects, we have the operating system actually, which is loading the files, the sys files, and now we have a known component which is handling the load process, and that also includes the reload process for the online change. TMX files are signed by a certificate comparable to the operating system certificates, which you know from the 64-bit operating systems, but we are providing such OEM certificates, and we'll have a look into that in a couple of minutes. For sure, the test mode of the operating system is again available for the TMX files. So you could directly start development and investigations after the webinar without any interactions to Beckhoff or any third party. When we are talking about version C++ project, which built the, let's say, foundation for the online change, then the version is defined within the TMC file. You know, we have this TMC editor, I have a screenshot here, and then in the upmost node, you have the class factory information, and there you have, as a new field, the version. This version is by default, it's a version 1. It's configured here, and this will be used whenever the C++, the version C++ project is published, and this is sticked to one repository. This repository is comparable to the PLC repository, where we have libraries which are ordered by vendor and the library name and the version. We have here, again, we have the vendor information, and we have the class factory name, which is something comparable to the library name. And then we have the version. And all this is stored within a repository on the engineering, but also on the target system side. So an activate configuration will transfer the required files from the engineering to the target system whenever it is required. So you will only have the startup versions during the initial activate configuration. If you're then afterwards doing an online change, the engineering environment will be able to transfer the new version to the target system, which were not transferred during the initial start, and put that into operation there. Okay, ITC online change, that's the interface your module needs to implement. What that for? As a first part, it's there for showing TwinCAT this module is able to be online changeable. The interface itself consists of two methods. The first one is prepare online change, and the second one is perform online change. So a slight difference in wording, but quite important. Prepare online change is a call to your code, so you could implement, if you would like to, the new module to prepare itself for an online change. During this preparation, the old code is cyclically still executed by the task. So it could be a long-term running method call where you're doing operations on data, maybe from the old module or from anything else, acquiring which is not about to be cyclically changing, because everything what you would calculate within the prepare online change method could be outdated immediately, because the cycle update method is called on the old code again. And that's the reason where we have the perform online change for. So after maybe long running prepare online change, we have the hot phase of the online change, the perform online change. And this code is also provided by you if you would like to. And this is for gathering, for example, the internal states of a PID controller or so from the old module. So the data which is cyclically changing and adapted to the current situation. After this perform online change, the cycle update call from the task will then go to the new module, and the old module will get destroyed from its memory there. So you could program to take over data from the internal stuff of the old module or any other component of TwinCAT, but the data areas are taken over for you. So TwinCAT takes care about the data areas. These are provided consistently from the old module to the new module. All these prepare and perform online changes only for taking over internal data, parameters which might have changed, and so on. How is the online change actually be triggered? Well, it's a menu in the engineering environment. We have this new tab here, Online Changeable Objects, and this online version on the right side is a drop-down box where you could select the version you would like to have, and then right-click on the tab, Apply Changed Online Object Versions, and then the process in the green box is initiated or started. So after these click on Apply Online Change Object Versions, these prepare online change in the code would be called, and afterwards the perform, and afterwards the cycle update gets triggered by the task. Before that, of course, the file copy would have taken place, so your version needs to be sent from the engineering to the target system if it's not already there. Okay, which component is actually loading the code you're coding, the binary there? Well, in the driver projects of TwinCAT C++, this is the operating system. The build process produces a sys driver, and the sys driver is actually loaded by the operating system. TwinCAT then takes care about the runtime there. Between that, the signing is checked for 64-bit systems by the Windows operating system. If you have a officially signed certificate, then everything is fine and the machine could go to the run mode. If you do not have that and you have a self-sign for development purposes, you need to establish this test mode of the operating system. And the same is true for the TwinCAT loader, which we have implemented for 4024. This is loading not sys files anymore, but TMX files. We also have a signing. We have the signing actually for 32 and 64-bit systems, so it's more consistent. We don't have this history of Windows with 32-bit systems where they haven't introduced the signing. And if you do not have a countersign certificate, so if you only have created it locally on your disk, then again you need the Windows test mode for establishing or for putting your TMX module to the run mode. This is done by the TwinCAT loader, and the TwinCAT loader is adding the capabilities for applying this online change capabilities, so to reload actually the code. Okay, so how to generate such a certificate? There's one menu, software protection, within the engineering environment, and you have a button, create new. Then you are providing some information, and that's it. That's a file on the disk, the certificate. Within your version C++ project, you would use or you would configure within this property page, which is also new in 4024, the certificate name, so the name of the file, together with the password. Well, The people listening and using a version control system right now will raise their hands and say, well, that would mean my password is going to the solution files, and the solution files is persisted in the version control server, which would mean my password is distributed in my company, and I don't want to have that. Correct. So whenever you are using the version control system or any version control system, please use the TcSign tool, which is a small tool which is putting your password to the registry of your Windows system. And that means it's not stored in the solution anymore. So whenever version control is in place, please use the TcSign tool, which is also documented in the information system. When you're not using that, you could think about putting it here as a short way into the solution. That was everything on the engineering side you need to do. On the target system, if you do not have any Countersign certificate, then you need to enable the test mode, like you know it from the sys files. And during the first activation, you will get an error. You will get this warning here, please import to add OEM to trust list. This is one advantage of our TwinCAT loader, which is not done by the operating system. You are able to configure TwinCAT to only execute code signed by 1 or 2 or 3, so a list of OEM certificates provided by Beckhoff. Okay, so this means you have a white list. You have a white list of signed code which will be executed. Okay, how to configure this white list must be the next point, right? If you're logging in, so who owns the controller is done by the administration account, right? Whoever has administrative access to the controller should be able to actually perform any changes to the controller. So we are providing with this first activation a rec file on the target system, and if you are the administrator of this device, you will be able to execute that rec file to put the certificate to the whitelist. So we are using as the administrator account of the operating system to authenticate who is able to put something on the whitelist and who is not. Afterwards, you will develop your TCOM modules, your C++ code as usual, and only for a release. So if you would like to execute your code without the test mode, then you're going to Beckhoff and acquire a countersigned OEM certificate. That's what we are talking about on the next 2 slides. So how to actually countersign such OEM certificates? So OEM certificates, they are stating that you have a private key there, you need to take care about that, it's not lost. And this is checked by Beckhoff if the data which is provided during the initial creation of the certificate is actually belonging to the requester. So for doing this verification, we have established a new order number, which is TC0008. And this is starting, let's say, the extended validation process between you as a customer and Beckhoff as the one who is checking the data. On the international side, where I assume all of you are coming from, we have TwinCAT product specialists in all countries, and these are able and trained to actually do this local verification between the submission of your certificate and the data which is belonging or is submitted to that process. Okay, so this was about the TwinCAT loader and the certification process there. If you are already developed TwinCAT C++ drivers and you would like to change to these new features, we have a migration guide in the information system. So there's a small how to convert a traditional driver C++ project to a version C++ project. Then you are within the repository with the TMX file and the TwinCAT loader. If you would like to go one step ahead, then you are able, with the second part of the tutorial, to refactor your code or your TCOM module to actually implement the OnlineChange interface. So for both steps, there are how-tos available in the information system, and you could change or migrate your code from the old drivers to the new C++ projects with version information. Okay, let's have a look at the from C++ to the Matlab Simulink part. In Simulink, we have this model kind approach where we are programming a model, and then we are generating C++ code out of that. And this C++ code is now compiled first via an automatic build process to the target system or to the engineering, where you are instantiating such modules and could put them on your controller. So it's quite natural that we are making use within this tool chain also to use the OnlineChange feature. And that's what we are about to release, let's say end of the year or beginning of next year. Then you have the option to export or to generate the C++ code out of Simulink in a way that it's online changeable afterwards in the TwinCAT runtime system. For sure, as in the C++ world, you need to take care that you do not change your data area, so not change your input and output variables, but the model itself could be changed. This is a first glimpse to the new configuration parameters of the TE1400, where you see that you have simply checkboxes. Yeah, I would like to use that. I need to have a lowest version of 4024, and then I have the signing environment for x64 Windows loader, and what's missing here currently is the TC sign process for the OEM certificates. And this is one point, of course, for C++, but also for the Simulink integration. We are providing the old ways, the drivers and the signing with the operating system certificates in the same way with 4024 as we have done that with 4022. So we are not discontinuing that. We are supporting that as before. It's just all this TwinCAT loader, OEM certificates, version C++, it's only an add-on. It's only an option for you to make use of it, or you could stick to the old process if you are familiar with that and you don't need to have the new features. If we have versioned modules, either from C++ or from Simulink, of course you need to define which version should be loaded. So during the instantiation in the engineering, you now have these possibilities of selecting the different versions, which we have here. As an example, we have one module or two modules with different versions here for the selecting, but we also have the traditional not versioned option, of course, here, and you're simply selecting the instances like you would like to have them. Okay, that was Matlab Simulink, and now a small speed run through the OnlineChange or through a project with OnlineChange capabilities. First, you see that we have this driver project, and next to it we have the version C++ project as a project template or the project with that when you're starting it within the engineering environment. A new project is also always accomplished with a module, so we have different module templates. And one new module template is an online changeable module class. So you could select this. If you would select this template without having the version, before you would get an error message that it's not capable because it doesn't make any sense to put an online changeable module into a non-versioned project. Next step, name, you know that from before. This is quite interesting. We have seen already that we need to configure the certificates. Before that, we have had this configuration by environment variables, and we have enhanced the property pages of the C++ project now for actually doing more configuration within the project. The same is true for these certificates. So we have within the property pages, we have this TC sign page, and there you're configuring actually the name of the certificate, so the file name, as well as the password. So it's right-click on the C++ project, properties, and then this dialog is opened. As the next step, we would now investigate the code, especially of the cycle update method. And then there you see the code, you know, we are just taking an input value and adding that to the output via a member variable called counter. Version. The version is within the TMC editor being definable. So if you're opening the TMC editor, you see on the topmost node that we have this class factory definition together with the version. So it's version 1 here. Now we are just publishing all the default code which was generated for you. We are changing this version to the version 2. And as a code change within the speedrun, we are simply exchanging the plus equals by a minus equals. And that means that our version 2 is actually decrementing, where our version 1 is incrementing, like you know it from before. Next step, we need to publish this version 2 to our repository. Now, these are the steps you are familiar with, I believe. If you have used TwinCAT C++, then you are instantiating one of these modules, you're generating a task for it, you're assigning this task to the module. Nothing has changed on this side, so you know these steps from before. But we have this one new menu in TCOM modules, online changeable objects. There we have this drop-down box, and after a first ignition or a first switch to run mode, we are able to go to this online version drop-down menu and select the new version which should be put into run mode. Right-click, apply changed online object versions, will establish or perform the online change actually, and you will get a small pop-up box stating that this was successful. If you're now using the inputs value and change that to 1 or to any value, you could observe that the output value is either incrementing or decrementing depending on the version which you have put into run mode. So this is actually the online change with TwinCAT C++. As a small summary, C++ programs, online change means basically reloading of the tmx files. Data areas and the mapping of that needs to be untouched. On the other way, it wouldn't make, you don't have the possibility to do the online change. TwinCAT is able to submit new versions without going to config mode. So it's comparable to the PLC, but not completely the same. We are also providing that with the TE1400. As I said, end of this year, beginning of next year, maybe. The TMX files are signed by an OEM certificate, which could be generated locally right now after installation. As long as you are working with the test mode of the operating system, this will work. For the delivery of your machine or the controller, you would need to have this ordering of the OEM certificate validation process, which is TC0008, where the product specialists and the sales could guide you through the process. That's it from my side. So all questions we got in between were answered by my colleague Knut Güttel. If nothing is right now popping up, I would like to thank you for your attention and say goodbye for today. And this was the last webinar for the 4024 update. So thanks for your attention to the whole series if you have participated. And we are sure we will provide you new great features in the next future. Thank you and bye-bye.